Hey guys, welcome to the video for equations and inequalities with variables on both sides. So this is kind of like a build-up of just solving regular equations, multi-step equations. We're going to add in something that we haven't really talked about yet, which is inequalities. Our essential question is, when and why does the inequality sign flip? We'll answer that probably after, I think, a few problems, but we'll go ahead and begin. If there are variables on both sides of the equation, you need to move one. I'll put that in quotations, right? You need to move one by either adding or subtracting. Either add or subtract to move terms from side to side. There's no other way to do it, right? So we're going to go ahead and go into number 1. Number 1 is 7 minus 8x equals 4x minus 17. Okay, and we just mentioned, if you have variables on both sides, you need to move one of them to one side, right? So they either need to be all on the left or all on the right. I like for all of them to be on the left, so I'm going to go ahead and move the 4x over. Now, where am I going to subtract the 4x from? From the 7 or from the negative 8x? I'm going to subtract from the 8x, right? And why do we do that? Well, we need to make sure they're like terms. So since 7 and 4x are not like terms, I'm going to subtract from the 8x. I'm going to go ahead and draw this wall down. Like I mentioned before, I'm not going to do it all the time, but since we're kind of getting into the gear of things, then I will go ahead and write that for a few problems. So on the right side, this canceled, right? 4x take away 4x is now 0. And on the left-hand side, I now have 7, and then I have negative 8x minus 4x, which gives me negative 12x. And then this equals, and we'll have negative 17 on the other side. All right, the next step here, again, we want x by itself. We want the variable alone. If we want the variable alone, we're going to need to subtract 7 first. And then negative 17 minus 7 is going to be negative 24. Once we get to this step, to get x by itself, well, we know that negative 12 is being multiplied to x. So in order to get rid of negative 12, we need to do the opposite operation, which is going to be division. And if you're watching and you're not taking notes, you should be. So either get out a piece of paper or make sure you printed out these notes beforehand. So we have negative 24 divided by negative 12. So this is going to be 2. So we have x equals 2. Now how could I check this? Well, I could plug 2 back into the equation for anywhere I see an x, and then I would get hopefully the same thing on both sides, right? You want to make sure your sides are balanced. Now, if you decided to do it differently, so let's see if we get something different, if I did something else at the beginning instead. So at the beginning, I decided to subtract 4x from both sides. Well, you're like, well, what if I decided to add 8x to both sides? Would my answer change? Well, let's check. So if we added 8x to both sides, what would happen? All right, so we have 7 equals 12x minus 17. I need x by itself, so I'm going to go ahead and add 17 to both sides. 24 equals 12x. Divide these both by 12, right? We want this x by itself. So I have x equals 2. Did my answer change? It did not, right? So it doesn't matter which way you do it. Regardless of the way you do it, you're going to get the answer the same. So as long as every move you make, every calculation, every every movement you make, when I mean by movement, I mean like adding or subtracting. As long as everything you do is mathematically correct or legal, then you should be getting the same thing. All right, number 2. 6x minus 6 equals 1/2 times 4x plus 8. So here I see parentheses. I also see a fraction, and I know all of us hate fractions. Like, we tend to grow up not really liking fractions that much, right? So how do I get rid of those parentheses? Well, in order to get rid of the parentheses, and I see a number on the outside, let's say there was a 3 on the outside, how would I get rid of it? Well, I would distribute, right? We would use a distributive property and distribute. So you're going to do the same thing. Just because it's a fraction doesn't mean you treat it any different. So what is 1/2 times 4x? That will be 2x. And then 1/2 times 8 is going to give us positive 4. And then I'll copy the other side from earlier, from what it was. Now we're back to this kind of the same situation we were in for number 1, right? We have a variable on both sides. I need to move them to one side. I like to move them all to the left. So I'm going to go ahead and I'm going to subtract 2x on both sides. Are you wrong if you decided to add 6 first or subtract 4 first? Doesn't matter, right? You're not wrong. But my goal is to get only one variable, so that's what I'm doing first. So 6x minus 2x is going to give me 4x. And then 4x minus 6 equals positive 4. My next step here, I'm going to add 6 to both sides. And then I'll have 4x equals 10. And then I'm going to divide both sides by 4. And then I get x equals 10 over 4. Well, what is 10 over 4 simplified? I would need you to simplify that for me, right? So I could technically divide 10 over 4 by 2. So I'm going to divide this by 2 over 2. And I get 5 over 2. So that means x equals 5 over 2. Well, you're like, well, can I leave it as a decimal? And I'm like, sure, I don't care if you leave it as a decimal. There is a exception though, right? I only allow you to use decimals if it's a nice decimal. So if it's a decimal that's repeating, like 1 over 3, that's 0.3 repeating, I don't want you to give me a decimal. I don't want 0.3 with a bar over it. I don't want 0.3 a bunch of times on your paper. I want you to give me the fraction. I need you to be exact because that's what I care about. I need it to be an exact answer. So this one does come out nicely. It does become 2.5, I believe. I'm going to double check myself here. I don't want to be crazy. Alright, so it is 2.5. So those are the same thing. And I don't really care which way you do it, right? So as long as everything you do is mathematically correct, I don't really mind. But if you're going to do decimal, it has to be exactly correct, right? It can't be repeating. Alright, I'm going to go skip this problem. I'm not going to go over that one. If you'd like me to, you can come before or after school and I can go over it with you. Alright, inequalities. What are the 4 types of inequalities we have? There are 4. And you probably I don't even know what an inequality is, but you've seen them. You've seen them since probably first grade, okay? Inequalities include these symbols. And you're like, okay, I've seen those before. So, now I ask you, what are their names? Well, you know that there's probably a less than, a greater than, a less than or equal to, and a greater than or equal to, but you're like, I don't really remember which one's which. So, here's a little trick. If your sign kind of looks like this, right? Think of it less than. Okay, it looks like an L kind of. Your little L's kind of tilted. So, if your sign is pointed like that, that means it's going to be less than. So, for our first one, we're going to have less than, which would mean the second one would be greater than. The next one here would be less than or equal to. And then the last one would be greater than or equal to. So if you ever forget, you can always draw a little L on your paper to remind you. Oh, if it looks like an L kind of, it's like a tilted L, it means less than. I'm going to move this really quick because it's bothering me because it's not super helpful where the location is. Okay, so those are our 4 types of inequalities. Now let's talk about keywords to look for in word problems. So you might be in the situation to where you actually have to solve a word problem, and you might have to set up a word problem given information, so you have to set up the inequality for it, right? So our first one, our 2 keywords that we see first are more than and less than. Now I'm going to go ahead and I'm going to number my inequality signs. 1, 2, 3, and 4. So my first keyword is more than. So which one of these signs do you think would indicate more than? 1, 2, 3, or 4? Well, it would be 2 because you want greater than. So this would be the more than symbol. And if you want to in your notes, you can just write the number 2 if you already numbered your inequalities up there. But I do want to go ahead and just write the symbol. So that means less than would be the other way. Let's talk about at most and at least. So if I'm telling you that you can put at most 5,000 pounds on an airplane, do you want to put more than 5,000 pounds or less than 5,000 pounds? You want to put less than 5,000 pounds. You could also put equal to 5,000 pounds. So at most would be something that's either less than or equal to. So you want at most or less than that. Or not at most, either the same or less than that. At least would be different, right? So if you needed to be at least 48 inches to ride the ride, you need to be 48 inches or more. So you would have to be either greater than 48 inches or equal to 48 inches. So that's going to be your greater than or equal to. Again, if you kind of forget, think about word problems you might see with those keywords in them. Maximum and minimum. Okay, kind of same thing. If there's a maximum weight limit, that means that your weight has to be either less than or equal to that maximum, right? So then the minimum would be the opposite. And then no less, no more. If I'm saying you can be no less than 5, or you can only eat, oh wait, I'm trying to set up. My English is kind of bleh. If you have to eat no less than 5 fruits a day, that means you need to eat 5 fruits or more a day. So you need to eat greater than or equal to that amount. So no less than that. So the no more than would be the opposite. Okay. All right. Now I have a little star here. Steps to solving equations. So we just learned how to solve equations in the last set of notes. The steps for solving an inequality are the exact same. Nothing different. There is one extra thing you might have to worry about, and I'll go ahead and we'll talk about that after we do a couple problems, but you do want to know that they're the same exact steps. All right, so we're going to go ahead and solve inequalities now, and we're going to graph them. So number 1, so you have 5x minus 3 is greater than 6. Okay, I need to solve this inequality. Remember, it's the same steps as solving as an equation. So if this was an equal sign, what would you do? First instinct would be, I need to get my x by itself. So I'm going to add 3 to both sides. So I have 5x is greater than 9. Okay, and then my next step here, I'm going to divide both sides by 5. So I have x is greater than 9 over 5. And that would be my solution or set for my inequality. If you wanted to do decimal, you may. I believe it's 1.8. I'm going to go ahead and box that, but I'll check in my calculator really quick. 9 divided by 5. That is 1.8. So I allow 1.8 because 1.8 is a nice decimal and it ends perfectly. I don't want you to just I don't want some weird decimal that keeps ending and you round it. I hate when people round. So do not round unless I ask you to, right? Now I'm going to graph this on a number line. So we've probably graphed on a number line in elementary school and in middle school. Let's review a little bit. So go ahead on the side of your notes and draw 4 inequality signs. You have these 4 here. If I have less than or greater than with no line underneath, my circle when I graph it is going to be an open circle. Okay? If I have less than or equal to or greater than or equal to, I'm going to have a circle which is filled in. So you will fill in your circle. Okay? So, open, you have less than or greater than, close as equal to. All right, so just think, because for these 2 signs, I write more, I'm going to fill in more in my circle. So that means on my number line here, for x is greater than 9 over 5 or x is greater than 1.8, I'm going to have an open circle. And then I want you to just go ahead and write that number. I don't need you to number the number line for me. I don't need you to find 1.8 for me. I just want you to just put that number there. Now, x is greater than 9 over 5. So x is bigger than 9 over 5. So where are the numbers greater than 9 over 5? Are they going to be located to the left of the line or the right of the line? They're going to be located on the right of the line, right? So if we think about our number line, we have 0, 1, -1, -2, 2, right? All the numbers that are big are on the right side. So if you want something greater than, you're always going to shade to the right. You don't have to shade like that. You can also shade like this. This is also an appropriate way to shade. If you want to shade like this, you may. So I'm a little weird and I just like to do little squiggles. So that's how I'm going to do it. Okay, and the reason why our circle is open there is because it's not equal to, right? So it doesn't include 9 over 5. It's everything bigger than 9 over 5. It doesn't include it. If it included it, it would be a closed circle. All right, number 2. So number 2, I'm going to go ahead and I'm going to shrink these because I need them to be moved. They're in my way, kind of. All right, so Here in number 2, I have 2 times x minus 7 is greater than or equal to 4 minus x. I see a set of parentheses, so I want to go ahead and distribute. So I have 2 times x, which is going to be 2x, and then 2 times negative 7, which is negative 14. Okay, and I'll go ahead and copy everything else down. And again, we're back to kind of where we were. We want, or in the very, very first example problem where we have variables on both sides. So if we have variables on both sides, I want to move them all to one side. So I'm going to go ahead and I'm going to add x to both sides. Now where am I going to add x to, or add x to? I'm going to add it to 2x or negative 14. I'm going to add it to 2x. I want to add it to the like terms. If they're not like terms, they can't be added. So then I have 3x minus 14 is greater than or equal to 4. Now I have 3x minus 14 is greater than or equal to 4, so now I'm going to add 14 to both sides. And that's going to give me 18. And then my last step here, I'm going to get x alone by dividing by 3. So then I have x is greater than or equal to 6. So this one was a whole number. So the last problem, we didn't have a whole number, but that might be the case sometimes, right? All right, am I going to have an open circle or a closed circle here? I'm going to have a closed circle because it is greater than or equal to. So I'm going to have a closed circle, and we're talking about the number 6 here. So I'm saying that x is greater than or equal to 6. So x is bigger than or equal to 6. So all the numbers greater than 6 are going to be to the right. Right, like 7, 8, 9, those are all going to be on the right side there. And remember, we're closed because it is equal to. So that means it could be 6 or it could be more than 6. All right, important note. If you multiply or divide by a negative number, you must flip the sign. Now, this is a rule that you might have encountered back in middle school when you were learning like pre-algebra and stuff. So if that's not something new to you, good. If it is, then welcome, right? So if you divide or multiply by a negative number, you must flip the sign. And it is only in that step that you flip the sign. So you're dividing by it or multiplying by it. So let's go ahead with number 3. I'm going to go ahead and do the left side first before I look at the right side because I do see 2 sets of parentheses here. So I'm going to go ahead and distribute on this side. Negative 2 times 4x is going to be negative 8x. Negative 2 times negative 8 is going to be positive 16. And then I can't simplify that side any further, so I'm going to move on to the other side. And I'm going to do 4 times x, which gives me 4x. And 4 times negative 2 to give me negative 8. Now, like I said, I like my x on the left side, so I'm going to go ahead and move it to the left side. Doesn't really matter. I'm going to go ahead and subtract 4x on both sides. So this 4x will go away, right? If I have $4 and I take away $4, I now have no dollars. And then I take away 4x on this side. Well, what's negative 8x minus 4x? Negative 12x. That's going to add 16 greater than negative 8. So don't forget that little negative sign. Some people like to drop that and forget about them, but he's still there. And then here I'm going to subtract 16 because I want my variable by itself. Oops, that's not a 16. Negative 12x is greater than negative 24. The last step here is going to be to divide by negative 12. And then I have x is greater than 2. I think that's right. Is that right? All right, am I done? Did I do everything correct? If you caught it, good job. So, what did I forget to do? I forgot to flip the sign. And what step? You're like, whoa, what step was that? I don't remember. You see how at the very bottom right here, I divided by a negative number. If I divide or multiply by a negative number, my sign needs to flip the other way. So, this sign is no longer a greater than sign. It is now a less than sign. Very important that you don't miss those kinds of things. Because, you're in the groove of things, then you forget. So, make sure you don't forget. So, is this going to be an open or a closed circle? It's going to be an open circle. And I'm going to have 2 there. And I'm saying x is less than 2. So, where are all the numbers less than 2? The left or the right? The left. All right, moving on, number 4, we have 3 is less than or equal to 7 minus 2/3 x. So we talked about in the solving multi-step equations notes how to get rid of fractions. So if we hate fractions, we multiply it by the least common multiple. The least common multiple is multiples of your denominators, and it's whatever the smallest that you have in common. So for example, if I have 1/2 and 1/5, right? Let's do all the multiples. So what are my denominators? Actually, let's just change that to like 3. It doesn't really matter what your numerator is. What's your denominator? Well, your denominators are 2 and 5. Let's list some multiples. So we have 2, 4, 6, 8. Sorry, we can just keep going on and on. 10, 15, 20, 25. And we can keep going on. Well, what's my least common multiple here? It's a number that they have in common that's the smallest number they have in common. So in this case, it would be 10. So you would multiply everything in that equation by 10. Well, here I notice that I only have one fraction, so I'm going to multiply everything by that denominator, which is 3. So since I multiply that right side by 3, I also have to multiply the other side by 3. And notice I put parentheses around everything. So the only thing that I didn't put a parentheses around was the inequality sign, right? So anything that you see has to be multiplied by whatever you're multiplying by. So here, 3 times 3, that's pretty simple. That's going to give us 9. And my sign didn't flip, right? I didn't multiply by a negative number. And then on this side, I have 3. I'm going to kind of distribute backwards here. I have 3 times 7, which is 21. And then 3 times negative 2/3 x, which is going to give me negative 2x. And then in this step, I realized, oh, I don't have any fractions anymore. I like what I'm seeing, right? Okay, now I have 9 is less than or equal to 21 minus 2x. I want the variable alone, so I need to, before I can divide or multiply anything, I must add or subtract. So I'm going to subtract this 21 on both sides. So 9 minus 21 is going to be negative 12. And then the last step here is to divide by negative 2. I'll do that in a different color because I like doing things in different colors. So negative 2, negative 2. X, and remember I have to flip the sign. I divided by a negative number, so I'm going to flip the sign and I get a 6. So I have 6 is greater than or equal to x. Now I'm going to graph this. And when I graph this, I have to think about, is it open or closed? It is closed. I have a 6 underneath. Now I'm saying, let's read this left to right. It says 6 is greater than or equal to x. So what is bigger, 6 or x? 6 is the biggest. That means x has to be smaller. Well, where are all the numbers smaller or less than 6? They're on the left. And you're probably thinking, well, that's a greater than sign. Didn't we say that greater than is going to be on the right? Yeah, it is a greater than sign. But what's greater, the 6 or your x? The 6 is greater. That means the 6 is the biggest your number could ever be, right? X has to be some number that is smaller. And all the numbers that are less than or smaller are all going to be on the left. So this is flipped around like normal, right? So we've normally been seeing x on the left. So let's see, x is here, and over here, x is here, x is here. So we're used to seeing x on the left-hand side. But in the case it isn't, you have to be able to read that. So x is now on the other side, so you have to make sure you can turn your brain around and read. Okay, it says 6 is greater than, which means 6 is the biggest. All right, moving on. So this is our last example before we move into the word problems. So go ahead and do that. I'm excited. All right, we have negative x minus 5 is greater than negative x minus 1 in parentheses. Well, first thing I see is parentheses, and I need to get rid of them. But I'm like, well, there's no number attached on the outside. What am I supposed to do to get rid of it? Well, what's technically in front of those parentheses that we don't really write? Technically a 1, right? So we could technically distribute a negative 1. Oops, I did. I messed up my shading because I hit undo too many times. I'm going to distribute that negative in. So there's technically a negative 1. So negative 1 times x is going to be negative x or negative 1x, whatever you're comfortable writing. And then negative 1 times negative 1 is positive 1. And I'll go ahead and copy everything else I see down here. So everything else is the same, except now I've distributed and gotten rid of my parentheses. But now I have variables on both sides, and I want to move my variables right to one side. So I'm going to add this x to both sides. Remember, this is where your sides are. You can only add or subtract to like terms. So if I owe you $1 and I give you $1, I now owe you nothing. What about over here? I owed you $1, I gave you $1. Do I owe you anything anymore? No. So there's 0. So it has canceled out as 0 x's. So now all I have is -5 is greater than 1. Is that true? Is -5 greater than 1? Is it bigger than 1? No, it's not true. So what kind of solution is this? This is going to be no solution. Okay, moving into applications of inequality. So, Joey's plans give him a 5 gigabyte of, Joey's plan gives him 5 gigabytes of data for $20. Each additional gigabyte will cost him $2. He wants to spend no more than $80. So here we're going to set up the inequality, and then I want you to solve the inequality. All right, let's talk about all of the information we're given here. We're given 5 gigabytes of data for $20. So no matter what, his plan is going to give him 5 gigabytes as long as he pays $20 every month. So the $20 is constant. That isn't going to change. So we have 20, right? So I'm going to go ahead and highlight that in orange, $20. Now you're like, well, why didn't you use the 5? I don't need to use the 5. We're not talking about the gigabytes here. We're talking about how much he's spending, right? And then it says each additional gigabyte will cost him $2. He wants to spend no more than $80. So we're trying to figure out what's the most amount of gigabytes he can use. So that means the thing that we don't know is the number of gigabytes. You don't know how many or how much gigabytes he wants. How much gigabytes? That doesn't sound right. All right, so the next bit of information is additional gigabytes will cost him $2. So we know each gigabyte is going to be $2. So do we know the amount of gigabytes? No. So that's where our 2x comes from. We have 2 for every gigabyte. So the gigabytes is x. So for every gigabyte, it's going to be $2. And then he wants to spend no more than $80 or $800? $80. Yeah, $800 would be ridiculous, right? $80. So no more than $80. So I know that 80 is going to be over here. Now it says no more than. So do I want to spend more than 80 or less than 80? I want to spend less than 80. So I need everything that I spend to be less than $80. So that would be the less than sign. But it says no more than. So could I spend $80? I could. So it could be less than or equal to. All right, there's only one more thing that we don't have. We don't have the operation that goes in between the 20 and the 2x. So the $20 that Joey's getting charged every month, plus the $2 for every additional gigabyte, what are we going to do with those two things? We're going to add them. It's going to give us our total for the month. So we're going to add those two things. So this would be our inequality. So if I ask you to just set up, that would be your setup there. But I also want you to solve. So let's go ahead and solve this. So again, we want x by itself, so we're going to subtract 20 on both sides. So I have 2x is less than or equal to 60. Our next step here, I just realized that all my colors were off. I was wondering why all the colors are boring. All right, and then I need to get x by itself, so I'm going to divide both sides by 2. So I have x is less than or equal to 30. And that's my solution. But what does that mean? If I ask you to write in a sentence, what does that mean? It means you can spend no more than 30 gigabytes. So you could spend, or you could get 30 extra gigabytes, you can get 20 extra gigabytes, but could you get 40? No, it has to be less than or equal to 30. So Joey can use an additional 30 gigabytes without going over $80. All right, so he could, in total, he could use 35, right? So he's already given 5 gigabytes for $20. And then every additional gigabyte is going to be $2. So that means he can use 30 gigabytes at most, because each of those will be $2, and that'll add up, right? All right, last one. The perimeter of a rectangle is twice the sum of the width and 6, plus twice the width. Given the perimeter is 24, what's the width? All right, so that was a lot of information. So go ahead and read that one more time to yourself, kind of digest that and be like, what did I just read? Okay. The perimeter of a rectangle is twice the sum of the width and 6, plus twice the width. let's talk about what perimeter is. What is perimeter? You're like, I'm using this word perimeter. What does it mean? Perimeter means I'm going to add up all the sides. So how do I find the perimeter of a rectangle? Well, the perimeter of a rectangle, let's talk about it. Let's draw a picture. Okay, I have a rectangle here, and I wanted to add up all the sides. How would I add up all of those sides? Okay, well, I don't know the sides, right? So I know I have a width here, a length, and a length. So I would take my perimeter, and I would say, well, I would add width plus the length plus length. Now, could we simplify this to give us some type of formula? Could we kind of figure this out and be like, maybe I could get somewhere. All right, well, I see some like terms, right? I see W plus W, so I say perimeter is 2 times W, right? Because that's 2 W's. And then L plus L, which gives me 2L. So this is the formula for perimeter of a rectangle. So if you ever forget it, you can always draw a picture and then come up with the formula yourself, right? You don't need me to tell you what the formula is. Yeah, it'd be nice, but I can't do that on a test for you. So if you ever forget, you can always come up with it by drawing a picture. Now you're going to talk about the fact that we have to translate now. So it's twice the sum of the width and 6. So twice the sum of the width and 6. So I see twice the sum, and that indicates to me parentheses. So we have to go back to day 1 where we learned about translating, and we said twice the sum indicates to me that I need parentheses. So twice the sum would be written as 2 with parentheses, and then it says of the width and 6. So the width I've already given the variable W. So I'm going to go ahead and put W and 6. And then it says the sum of the width and 6. So what operation is going to be happening between width and 6? It's going to be an addition sign because it says plus, or sum, right? So now that I have that, it also says after, here, let me actually, width and 6. And then I'm going to, I'm changing my colors so that I can see a little better. And this is plus twice the width. So twice the width, what is that? Well, twice the width would be 2W. So plus twice width, twice the width. And I'll go ahead and put that in blue. So I've kind of highlighted things for you here. And you're like, well, why do we even need the formula? Well, it kind of gave us the formula. So this is technically like our length, and this is like our width over here. This is technically our length, and this is technically just our width, right? We just have a W, and the length is now W plus 6. So yeah, we didn't really need the formula, but I didn't want to let you know where it came from. We will need it later on, though, however, so it is good to know. So it isn't super unuseful, right? All right, given that the perimeter is 24, keyword, perimeter is 24, indicates to me that it means an equal sign. So if the perimeter is 24, that means that all of this is going to equal 24. And if you wanted to, you could write the equal sign on the back if you'd like. Equals 24. Up to you. Doesn't really bother me that much, but I'm going to go ahead and write it on the other side because that's what I wanted to do. All right, now we just have to simplify. But let's look back at what I wanted us to find. What is the width? So we want to look for W because W was what we gave width to, right? So I'll even go over here. This is our width, and L is our length. So go ahead and distribute. 2 times W is 2W. 2 times 6 is going to be a positive 12. Okay, and then you're like, well, why are we not having an inequality sign? Like, why is this in the notes? Well, the title of the notes is Solving Equations and Inequalities with Variables on Both Sides, or just multiple variables. So in this case, it's going to be an equal sign, and it is an equal sign because it's giving us is, right? It doesn't say no more than, doesn't say less than, so this one will be an equal sign. All right, and then I want to look for anything that I could simplify, and I see some like terms. I see 2W plus 2W. So I have 24 equals 4W plus 12. Okay, so I combined those two terms into one. I'm actually going to go ahead and make this all orange so that the only thing I changed was the W's so you can see that, okay? So I just combine those W's, and then I'm going to go ahead and get the W alone by subtracting 12 first. So I have 12 equals 4W, and divide both sides by 4. And we have W equals 3. What does that mean? That means the width is 3. Awesome. Okay. So that is it for our notes for solving equations and inequalities. If you have any questions, please feel free. Go ahead and zoom out for that for you if you wanted to kind of like look at the big picture. If you have any questions, please feel free to email me or come in for tutorials.